Here we have the graph of f of x equals sine of x. We are going to get the graph of inverse sine of x by reflecting this graph through the line y equals x. Here's the line y equals x. It's a line that passes through the origin. You can see that c is 0 for this line. The slope is 1. The coefficient of x is 1. So that means this line makes an angle of 45 degrees with the positive x-axis. The tan of 45 degrees is the slope, which is 1. So this is what we get when we reflect through this line. We get the inverse function, written f minus 1 of x. Notice that the coordinates of a point on this curve get switched. So the x value of this point is 2.21. It becomes the y value of this point. The y value of this point, 0.8, becomes the x value of this point here. The two functions are equal at x equals 0. So for this point here, f of 2.32 equals 0.73, but f inverse of 0.73 is 2.32. So this is how you get the graph of the inverse of any function, just reflected through this line. I should point out, by the way, that this graph here is not a true function, because a true function has a unique value for any value x in the domain. Now, the domain of inverse sine of x is from -1 to +1. So you can see that the domain of inverse sine of x is the range of sine of x. The range of sine of x is from -1 to +1. So the domain of inverse sine of x is from -1 to +1. So all our x values are in here for inverse sine of x. So if we take any particular x value, to find inverse sine of x we have to go up to the graph of it, of course. But you see, a function should have just a unique value for each value of x in the domain. So for example, for this value of x, this value here is the inverse sine of x. Okay, we have to restrict the range of inverse sine of x so that each value of x in the domain has a unique value of x. So we can't have this value here. So basically we have to cut off the graph So for the graph to be a true function, we can only show this shaded part, the part that I've shaded in black. That means that for each value of x, we will have a unique value of f inverse of x. So that means if we draw a vertical line through x, this vertical line will only cut this black curve here that I've penned in at one point. So for each value of x, there is a unique value of f inverse of x. So we just ignore this red dotted line here and down here for this to be a true function.